Yeah, so we need to find the multiplicity of the Einstein solid. And this is the low temperature limit. Right? Okay, so we know what the multiplicity is. It's Q plus N minus 1 factorial over Q factorial N minus 1 factorial. True? That's the formula for the multiplicity. Okay, well, if these things are very large, you could simply ignore the minus 1. So you get Q plus N factorial. It's like N is a million or a billion, and Q is a million. Yeah. So N factorial. Okay. Well, you can't figure out this because these are such large numbers, so you change it into a logarithmic scale. So you ln both sides. So ln the multiplicity, ln the right hand side. You get ln q plus n factorial. Properties of the ln's. If you can expand this with ln, right? So this becomes ln the multiplicity, ln top minus ln the bottom. Yeah. So ln q plus n minus ln q factorial minus ln n factorial. Okay, now by Stirling's approximation, ln n factorial is just n ln n minus n, right? So this guy here becomes minus n ln n minus n. The factorial goes away. And then we can do the same exact thing with this guy here. So this becomes minus ln q ln q minus q. And applying the same exact reasoning on the first one, you get q plus n ln q plus n. Alrighty? So this guy here is this guy. And so we have q plus n, this needs brackets, ln q plus n minus q ln q plus q minus n ln n plus n. And if you FOIL this guy, you will get the q ln q plus n yeah.
You're just putting lns of
Right.
you just put ln on everything, just like ln
Yeah.
plus
ln everything, yeah. So we get oh wait, I forgot the q plus n term. Yeah, I forgot the q plus n term. So minus n minus q from this guy here, from Stirling's approximation of this one. So minus n minus q minus n minus q. So these two go away, and we have ln equals q plus n ln q plus n minus q ln q minus n ln n. Okay, now let's see how we're gonna work with this guy here. So let's move this guy and do the approximation on it. Ln q plus n is equal ln. You could factor the n out, and this becomes 1 plus q over n. And as we said, q is a lot less than n, so q over n is a lot less than 1. Right? So this becomes ln n plus ln 1 plus q over n. And in the limit that q over n is a lot less than 1, you could approximate this as ln 1 plus x becomes ln x. So this becomes plus ln, or plus, there's no ln, plus q over n. So plug the result back up there. So we would get uh, ln, the multiplicity, is equal to q plus n, and we've approximated this as, so this was an approximation, as ln n plus q over n. So we get q ln, let me see, minus, oh, we still have, minus q ln q, and the last term is minus n ln n. So we get q ln n plus q squared over n plus, so I'm just distributing here, n ln n plus q minus q ln q minus n ln n. So these guys go away. And we have left q ln n I'm going to factor out q, so q ln n minus ln q from these terms plus q plus q squared over n. So this becomes q ln n over q plus q squared over n. Now, if q over n is a lot less than 1, q squared over n is very, very small, even smaller. So this term goes to 0. And uh, and then we would get, so exponentiate both sides now, we would get the multiplicity is equal to e to the q ln n over q plus q, or I could just rewrite this as times e to the q, because then you can add these two terms. Okay, put this on the power. So this is e ln n over q to the q times e to the q, and the first term just becomes n over q to the q times e to the q. And since they're both raised to the q, you could bring them together and you get the final result for the multiplicity, ne over q raised to the q. This is for the limit where q is a lot less than n. Notice, if you look at the result where q is greater than n, what's the answer? This is just eq over n raised to the n. What happened? You just replaced the n with the q. You swapped the q with the n and the n with the q, which makes sense because mathematically all we did is we did an approximation where q was small compared to n versus n is small compared to q. So we did Taylor series expansion on the ratio of q over n rather than n over q. So you get the same. So if you were to forget one of those, you can just remember one, and for the other limit, you just swap the q's with the n, and you get the second one. They're identical, except whatever there's a q, you plug in an n. Whenever there's an n, you plug in a q. So the answer to our question is this guy here. Did you get there?
Where did you get the? How did you get to the canceling or to getting q term to?
The q term?
To getting the q term to go away.
Which one of them? Which q term? This term? Here, you just factor out n from this guy. That's where you're trying, because that's when this is less than 1, and you could just use the Taylor series expansion of ln1 plus x, which is x when x is a lot less than 1. So this just becomes q over n. ln1 plus q over n becomes q over n. You see?
Oh, that's after you do a Taylor series expansion.
Mm-hmm. Yeah. Because ln of 1 plus x is almost equal to x if x is less than 1.
Okay. The smaller it gets, the closer closer to x, I guess.
But
Alright. Okay, and then the that's for the numerator, what about the denominator? The q factorial.
oh, those you have to use Stirling's approximation on them. The look this ln factorial is n ln n minus n.
Yeah. Yeah.
Yeah,
I
so
have
you
that.
switch those with that.
I have that part. So I got q